Hello and welcome. In this lecture, we're going to be looking at the C++ equivalent of pure blueprint functions, which is const functions. We're going to see what this const keyword is, how we use it, and how it restricts what we can do in our code to make us safer. Let's dive in and see how it works. Over in Blueprint, we were able to make a function pure, and that meant that we could take away the need for the execution pins. Now, in C++, we can do something a little bit stronger, which is to make a function const. Now, what does it mean to make a function const? It means that that function cannot modify the state of your class, and it is actually enforced by the rules of the compiler. So let me give you an example. If I were to take our should platform return function, this is not a function that should modify anything in the class, and it would be an error really if we forgot that, because it would be weird if calling this and using it in an if statement actually changed the location of the platform, or if it updated the move distance or platform velocity. So to keep ourselves honest to that, we can make it const. And the way we do this is by putting the const keyword after the parentheses of the function. We often leave a space here as well. Now, in order for it to correctly match up to the function in the C++ file, we actually have to put that const keyword over there as well. Now, like I said, this now makes it an error to do anything that would modify the class. So if in should platform return I were to try and modify a class variable such as move distance, I might try and set move distance to 200. Let's see what happens when we go over to Unreal and hit the compile button. Okay, you can see that there's now an error. It does fail to build, and if you look at the error, you can see that there's something being said here about not being able to modify something because it's being accessed through a const pointer. Now, don't worry about that language. It's a little bit hard to interpret, but the point is the keyword const was there and it's saying it's not able to modify something. And that is crucial. Also, if you called any functions that aren't marked as being const, that's also a problem. So while it's fine to call getActorLocation, that is a const function, doesn't change anything, just gets the location. It's not okay to call setActorLocation. That hasn't been marked as const, and so it's not valid. It could be modifying the class. So any function that's not marked as const is not allowed to be called from within a const function. And so you can see a problem emerging. We can't actually call getDistanceMoved from within our should platform return, because should platform return is const, but getDistanceMoved hasn't been marked as such. So a quick challenge to you, get the distance moved const, make getDistanceMoved const. So in the header and CPP file, you're going to add that const keyword to let C++ know that it shouldn't modify the class. And does it compile now? Pause the video and have a go. Okay, welcome back. So we're going to go over to the header file first, and after the closing parentheses, we're going to add a space const, and then we're going to go back to the C++ file, and after distance moved parentheses, we're going to put space const. Now, the squiggly lines under get distance moved should update in a little bit of time, but if we go over to Unreal and hit the compile button, that will be the ultimate arbiter as to whether the compiler likes what we've done or not. And this time the compilation has succeeded successfully, which means that we have correctly updated our code. And that makes sense because there is nothing being called from getDistanceMoved that is not const. It's not trying to change anything. And where we are calling a function in should platform return, we are only using const functions. And this is a way for us to increase the safety of our code because functions won't be changing stuff without us knowing about it. Now, as a little exercise to yourself, you might want to go through and look at all the functions that we've been using up to now and see which one of them are marked as const and which ones aren't. You can do this by simply hovering over a function such as getActorLocation and seeing whether the pop-up that is included, whether after the parentheses it has const or not. You can see with getActorLocation, hovering over it gives me const. Hovering over getName also gives me that this is const, and it makes sense. Neither of those two should be changing the state of our class. Now, if I hovered over tick, You can see this one isn't marked as const, and that makes sense because tick is usually used for updating how a class is positioned in the world or any of the state of the class. And we've got our vector. If we hover over getSafeNormal, you can see that it's marked as const. That's because getSafeNormal doesn't actually modify the vector, it just returns a value with a new vector in it. So that's it for this lecture. We've learnt about adding const to our functions to increase the safety of our code. I'll see you in the next one.